Hello, my name is Joshua Fuller, and today I will be teaching you how to do the 2012 AP Calculus BC problem number 2. So first, let's read the initial part of the problem, and then throughout the video we can go through the subsequent questions. For t is greater than 0, a particle is moving along a curve so that its position at time t is parentheses x of t, y of t, close parentheses. At time t equals 2, the particle is at position 1, 5. It is known that the derivative of x is this, and the derivative of y is this. Those will be important later. So, let's move on to part A. So part A says, is the horizontal movement of the particle going to the left or to the right at time t equals 2? Explain your answer. Find the slope of the path of the particle at time t equals 2. Okay, so let's first focus on the first part of the problem, whether it's moving left or right. Now for this part, we're only going to be focusing on dx dt, because the x-axis is, if you look at a Cartesian plane, what determines left and right motion. This is the x-axis, this is the y-axis. So we can ignore dy over dt right now. Okay, now something, if you look at this, you can notice something. This will never be negative, which is important, because if the derivative of x over dt is less than 0, then it will be moving to the left, which should make sense, because this is the motion of x, it's the derivative of it's the change, so if it's getting smaller, it'd be moving this way on the number line. Conversely, if dx over dt is greater than 0, it'll be moving right because it is increasing and therefore moving this way on the number line. So looking at it, we can realize that it will never be negative because a square root can't be negative without getting into the realm of imaginary, and e raised to the t will never be negative either. So this thing can only be equal to 0 or a positive number. So let's just plug into and figure out what we get. So the square root of t, which is in this case 2, plus 2 over e raised to the t, which is in this case 2. If you plug that into your calculator, or just do it in your head, it equals 2 over e squared, which is very obviously greater than 0. So we are moving right. And your explanation for that, you could do this. Second part of the problem. Find the slope of the path of the particle at time t equals 2. So for slope, if you remember, that's equal to dy over dx. The issue is we don't have dy over dx. They just give us this weird dy over dt and dx over dt. So we had to do a little math to get from a to b. So this, if we think about it, is really equal to dy over dt times dt over dx, or the derivative of y divided by the derivative of x. Because these things cancel out, and you get that. So, to find the slope at t equals 2, let's divide the derivative of y by the derivative of x. So, sine squared of t over the square root of t plus 2 over e to the t. And we're supposed to plug in 2, so let's do that. Sine squared of 2, and we can bring this e up times e squared all over 2. And if you figure that out, it equals about 3.054. It's just that easy, folks. Part B. Find the x-coordinate of the particle's position at time t equals 4. So that's when this nifty little coordinate comes in. So we know at time equals 2, x is equal to 1. So let's just write that down, 1. So what this question is really asking is, what is the x-coordinate of the particle at t equals 4? But we can figure that out by starting where we know. We know that at t equals 2, x is 1. We can start there. And then we can add how much x is changed by. We can take where it started at t equals 2 and add how much it's changed up to t equals 4. And we can do that with our handy-dandy integral sign. So to integrate from 2 to 4, because that's where we started and that's where we want to end, of dx over dt, we're doing 1 plus the difference between the x-coordinate at t equals 4 and t equals 2. And so if you plug this into your calculator, you get 1.255. That's the x-coordinate. Part C. Find the speed of the particle at t equals 4. Find the acceleration vector of the particle at t equals 4 as well. So speed, if you remember, is equal, I'll just say speed is equal to the square root of the derivative of x squared plus the derivative of y squared. In this case, t equals 4. So you can just plug that in. The square root of, we already know x prime, because they gave it to us right here. So the square root of 4 plus 2 over e to the 4 all squared plus sine squared of 4 squared. That's the speed. And again, calculate a problem. If you plug this in, you get about 0.575. Second part of the problem. Find the acceleration vector of the particle at time t equals 4. So the acceleration vector is just the vector. It looks like this. But instead of, I'll write here, x prime of t, y prime of t, so the other derivative of that, it's x double prime of t, y double prime of t. So we have to find the derivative at t equals 4 of dx and dy. This handy dandy calculator problem, we can figure out that if you do dt of the square root of t plus 2 over e to the t at x equals 4, you get negative 0.045, and if you do the derivative of sine squared of t equals 4, this should say t, you get 0.9894. And there's your answer. There's your acceleration vector. D. Find the distance traveled by the particle from time t equals 2 to time t equals 4. And for this, we're going to need the speed equation again. Because if we want to find the distance traveled, we want to basically take the integral from 2 to 4 of the speed, because that's the same thing as finding the antiderivative of the velocity, which is the position. And if we chart out how far it's gone, if we chart out its position, we know how far it's moved. So 2 to 4 of x prime of t squared plus y prime of t squared, and we can write out this in a better form. Square root of t plus 2 over e to the t squared plus sine squared of t squared. And if you figure all that out, you get 0.6509 8. Boom. So now, if you're looking for additional problems, all the ones on the screen are good practice. Thank you for listening to my presentation.